announcing Blozo's battery torture test. The battery, the subject, my battery, my deep cycle marine battery, which serves as my station backup battery. The battery that provided 91.5 amp hours at a discharge rate of only 1.2 amps, right? Congratulations, Jay. W4 Zebra X-Ray Tango. Congratulations, Radioactive. Well played. Now I'm kneeling down. Forgive me the rough video, as if I've ever done anything other. Now, here's my battery amp hour tester, okay? You can see that the current battery voltage is 13.1. I'll show you that on my DMM in a moment. I've set it. Oh, man. You know who you are, you buzzkill. I really enjoyed killing this thing. And then I started thinking, damn, he's right. It's a $100 battery. And 1 amp is one thing, but we're going for 11.2 amp discharge rate. It'll terminate at 11.5 volts, okay? But I've got to be present to unterminate the high current load. I'm setting this for a discharge rate of 1 amp, okay? So this tester will add 1 amp to the overall discharge current. This load resistor, I've talked about it in the other video. It measures with wire, I believe it was 1.156 ohms or something anyway. It results in a measured current draw from the battery of 10.20 amps when the battery is fully charged. This is the current battery voltage. I love this meter. I can lock it on so it doesn't time out, and it uses 2 AA cells, which I've installed rechargeables in. I can leave it on forever and not care. The Fluke uses $5 9-volt batteries. The test setup, said resistor, and die-cast aluminum muffin fan, which screams, man. My only hope, hang on, gotta reposition. My only hope is that it'll keep that resistor somewhat cool. I had fantasies of a flaming load, but then I started thinking about so we'll see. Okay, the method. What I'm going to do is click that button, and that will start an immediate discharge of 1 amp. I'm going to grab that ring terminal connector and quickly slide it on that threaded post. I'm going to pull backwards so it maintains a constant discharge for accuracy. And I'm going to slide that washer and nut on it and cinch it down like I've done to the negative terminal. Okay, hang on. I'm going to pause you. I'll get it started. And when I feel heat in the load resistor heat sink, we'll click the fan on. Hang on. Okay, boys, we're underway. The voltage dropped to that already. And it's been, 20 seconds since we started the test? Let's see if we're developing some heat in our load resistor bank. It's starting to get warm, but it's not roasting yet. We'll have to see how hot it does get. Once it starts roasting, I'll turn the fan on. I'll bring you back. Hang on. Ah, Blitzen's such a good boy. He loves to keep Daddy company. Now, Peter, VK3 Yankee Echo, he's always barefoot. I've never seen him wear shoes. The Manic Mower, now he works in bare feet in his shop. Yeah, in Michigan, we're a little bit more civilized than that, man. So the heat sink, let me feel again. Hang on. Damn, we're only up to 0.05 amp hours, a 20th of an amp hour. We're down to 12.41 volts. The heat sink's getting nice and toasty. Let's get a breeze going. All right, guys, what say you? At the 11.2 amp discharge rate, what will the battery capacity be at the termination voltage of 11.5 volts? I suggest when you place your bets, when you make your guess, I suggest taking it out to the 10th of an amp hour. For example, 3.7 amp hours. What do you think, man? From 91 amp hours to... And another thing, man. Maybe I'm making this more complicated than it needs to be. The amp hour number that this displays when it's done is not the real amp hour capacity of the battery. Whatever time... Remember, this is a timer. That's what I'm using it for, is a timer. Whatever amount of time this displays when it's done with it, when it's at the termination voltage, I must multiply that amount of time by 11.2, and that'll give us the true amp hour capacity at the 11.2 amp discharge rate. Okay, man, maybe I ought to just shut up and let it do its thing. I thought I'd mention, if there's any question about me using this device with another secondary load, I'm basically only using this as a timing device. It'll stop and lock in when it reaches 11.5 volts, right? Marking the amount of time that the battery lasted at that current rate. However, the battery will still be discharging by that load resistor there. So I've got to be present. When this is done, then I can disconnect it all, and I'll have my number. Good guessing. 73.